HBase Architecture. HBase has two types of nodes, master and region server. There is only one master node running at a time, whereas there can be one or more region servers. The high availability of the master node is maintained by Zookeeper, a service for distributed systems. The master node manages cluster operations such as assignment, load balancing, and splitting. It is not a part of the read or write path of data. The region server
has one or more region servers running at a time.
Hosts tables, performs reads and writes of data. Clients communicate with the region server in order to read and write their data. A region in HBase is a subset of a table's rows. The master node detects the status of region servers and assigns regions to it. HBase Components. The image represents the HBase components, which include HBase master and, at the bottom, multiple region servers. The HBase master is responsible for the management of the schema, which is stored in HDFS. Region servers act like availability servers that enable the maintenance of a part of the complete data stored in HDFS based on the requirements of the user. The region servers perform this task by using the H-file and the write-ahead log, or WAL, service. The region servers always stay in sync with the HBase master. It is the Zookeeper that makes the region servers perform a stable sync with the HBase master. Storage model of HBase. The two major components of the storage model are partitioning and persistence and data availability. Partitioning is one part of the storage model, where a table is horizontally partitioned into regions. Each region is composed of a sequential range of keys and then managed by a region server. A region server may hold multiple regions.
Persistence and data availability
are also important components of the storage model. HBase stores its data in HDFS, does not replicate region servers, and relies on HDFS replication for data availability. The region data is first cached in memory. Updates and reads are then served from the in-memory cache, which is called the memstore. Periodically, the in-memory cache, or memstore, is flushed back to HDFS. The WAL stored in HDFS is used for the durability of the updates. Row distribution of data between region servers. The image describes the distribution of rows in a structured database using HBase. It shows how the data is sliced and then maintained in individual region servers, depending on the requirement of the user. This type of distribution ensures availability of data for a specific user. As you can see, with the data A1 through Z55, some data is split based on the index value. For example, null to A3 is in the first region server. A3 to F34 is then stored in the second region server, and so on. Data storage in HBase. Data is stored in files called H-files or store files that are usually saved in HDFS. An H-file is a key value map generated due to the MapReduce operations that are performed by Hadoop. When data is added, it is written to the WAL and stored in memory. This in-memory data store is called the memstore. H-files are immutable, since HDFS does not support updates to an existing file. To control the number of H-files and keep the cluster well balanced, HBase periodically performs data compactions across the HDFS cluster.